Welcome to the IIoT and Remote O&M webinar this morning for the food industry. And let's move on to the first slide here, which is the overview. This webinar will briefly display the many slides in this deck and focus on a few presentations by suppliers. So there's several different purposes. One is to show the depth of research in the McIlvaine IIoT and Remote O&M analysis in each industry. This provides a unique resource to project IIoT markets. And by the way, this meeting is being recorded, so most of the people who are going to be viewing this are actually going to be looking at the YouTube recording. Another purpose is to show the interconnection between components and process control systems. An important purpose is to establish the value of what McIlvaine has coined IIoW, or the Industrial Internet of Wisdom, to empower IIoT. And the food industry has many processes and each has many components. So improvements in valves, sensors, filters, centrifuges, pumps, fans, robotics, drives, etc., are needed to make process management systems more valuable and cost-effective. IIoW is maximized by deep analysis of each food manufacturer and systems to allow interconnection between personnel in the plants with each other and with suppliers. Process management systems will provide the equivalent of white papers about each component. With data analytics, the superior performance of better products will become clear. But what about superior products which are not already in the plants, or process changes which would really affect the performance of the components? These have to be probed, and the food manufacturer will benefit through leveraging IIoW to empower IIoT with wise crowd decisions through organized focus groups. And here's an example for variable speed drives. So you've got two plants. One makes fructose and another one makes protein. And in the fructose plant, you're recovering the energy rather than and reducing the amount of steam that's being used with mechanical vapor recompression. And that requires a fan, which also can utilize a variable speed drive. And all of that can be remotely controlled in the cloud through a process management software system. In plant number 2, which makes the protein concentrates, you have a dewatering subsystem with a decanter type centrifuge, and those decanter type centrifuges have very complex variable speed drives that recover the energy from the screw. And again, you've got process management software suppliers who will be monitoring the performance of that centrifuge and the variable speed drive. So you have all these different sources within each of the plants, and you take a plant such as ConAgra or Nestle or a corporation such as Nestle or ConAgra, and you have many different plants, and you have many different people that are going to be interested in variable speed drives. And we have found we've set up a system, for instance, for Berkshire Hathaway Energy, and the individual plant people can communicate with each other. And for instance, in the case of a filter, we found for condensate that the superior performance at one plant was not being communicated. Well, relative to the wise crowd decisions, we've run 9 hours of webinars for that for 2 of those plants within BHE, and they believe that they will save somewhere around $200 million due to what they coined as the wise crowd decisions, and we've started utilizing that term as well. So the markets for IIoT and remote O&M are likely to soar to 56 billion by 2030, or a 13% growth rate throughout the period. East Asia obviously was going to be show the biggest growth, but these forecasts include software and components which would not have been purchased absent IIoT, and products sold through different channels due to IIoT. So in terms of a supplier production-wise, the number of units is less than is going to be reflected here. But for the sales department, this is $56 billion worth of sales that's going to have to be handled differently than it is now. We're analyzing the purchases of all the different components for the 75 or 100 largest food companies, and these are the three largest, and here are the next three. But notice that of these companies, 7 out of the 10 are U.S. based, making the U.S. the largest purchaser at the corporate level. So with the advent of remote monitoring and IIoT, you are increasingly going to have purchasing accomplished at a corporate level, or at least specifications made. So the United States is going to be a very important cog in the food decision making of the world in the future. The U.S. rankings are somewhat different, with ConAgra showing up as the number 10 supplier. Nearly half the food processors are moving forward with IIoT. Obviously, the IIoT needs to be justified based on food equipment effectiveness. We are forecasting many of the components. We have separate services that we've had for decades on pumps and valves and liquid filtration and cross-flow membranes, fabric filters and scrubbers and clarifiers and centrifuges. And for instance, on the centrifuges, we've had extensive analysis of variable speed drives. There have been some variable speed drive manufacturers who just furnished the variable speed drives for decanter centrifuges. That's all they have done. Now it's expanded to where the ABBs and others are supplying those drives. Cartridges, compressors, treatment chemicals, instrumentation, process control, emissions monitoring, and an HVAC. Let's take a deeper dive on pumps, and you can see that we are taking each of the largest manufacturers and figuring out how much they're going to spend on the different types of pumps. And you can see here that ConAgra is going to spend $1.9 million average per year, and all of that virtually will be in the Americas. The concept here is not that this is a precise number and we can identify particular projects. This is statistically the average that they're going to be purchasing per year based on their size, and that the supplier, if he is working with them, is going to know about these projects long before they becomes official specifications and RFQs. In each of these industries, we already have very detailed forecasts, every country for the food industry, every type of valve, for instance, either here control valves and here on-off valves, which is a $1.2 billion market just for the food industry. Another way to look at the industry is by the types of products that are being made. And the dairy industry portion of the industry, certainly when it comes to combust, flow, and treat equipment, would be your largest, with fruits and vegetables, then soft drinks, oils, beer, so forth. So that's another way to look at it. The details of the processes are critical, and they need to be improved on a continuing basis. We just presented, for instance, here's where some of your slurry pumps are used, and HIP filters are used throughout. For instance, the beer processes, wine processes have all sorts of separation equipment in them, as well as, of course, you've got heat exchangers and all sorts of gas and liquid treatment equipment. Soy processing, similar, and the dairy industry, just the rotary pumps alone would be a substantial number. And then you have some extraneous systems that are common to a lot of these plants, and one would be clean in place systems for a lot of your equipment. And here you see the pumps and valves that would be used in many systems where you do have the need for hygienic certainly conditions, and the need to clean in place. So we picked ConAgra as an example of a deep dive into one of the food companies, and it's basically separated into two different divisions. And we are providing for each of these companies general forecasts of where their plants are, what kind of expansion plans they have, and the capital expenditures, what they might be doing in terms of environmental activities, and other aspects that would be of interest to the suppliers. We also have information on each of the plants, in fact, all the industrial plants in the United States, and we have certain other initiatives in Europe and elsewhere. But for instance, at ConAgra, one of their plants here has got a 6 million gallons per day wastewater discharge, whereas another plant only has far less than 1 MGD. So obviously having that kind of information is useful to the suppliers. And from EPA, we've been able to extract any toxic water discharges at each of these plants. We also have information on all the boiler systems, with the size of the boilers and the types of equipment that are being used. But obviously they all have all sorts of combust, flow, and treat equipment associated with them. The water reuse permits at all these plants become valuable information as well. And you get an idea of what is the future purchases for a company like ConAgra by on a broad basis, viewing the information on their long-term plans for both expansion and for environmental compliance. Obviously, these ConAgra is quite concerned with the most efficient use of water, and they are producing biogas at some of their plants. In fact, we're going to learn a little bit more about that in a minute. And the flow and treat projects are ongoing at many of these plants, lots of environmental projects, and there's all sorts of equipment at these plants. And anaerobic treatment is certainly in vogue at a lot of the plants there, and they're using centrifuges. And if they are generating biogas, they can use, in this particular case, a Cummins engine. And so in this case, they are using secondary clarification from Evoqua. But at this point, I'd like to introduce Jose Molina, who is with ADI. And Jose, could you explain a little bit about what about your application here at Milton and what is being achieved?
Certainly. My name is Jose Molina, and I work with ADI Systems. ADI Systems, by the way, has been recently acquired by Evoqua, so we're part of the Evoqua family now. Just touching briefly on the project at Milton, Pennsylvania. The city of Milton went ahead and developed this project, but the wastewater that's being treated at the municipal plant is, I would say, 95% of the load, or close to 100% of the load, comes from a ConAgra plant, which is the plant that makes products such as Chef Boyardee. So you have a food processing effluent wastewater, which is very high in strength, but it's all organic strength. It's all organic matter food, which is a perfect candidate for anaerobic digestion. So the project here consisted of taking that wastewater that was previously being treated aerobically by the city of Milton and treating it instead in an anaerobic digestion system. It's called the ADI BVF reactor. We have two large reactors that receive that wastewater from the ConAgra plant. The load, this is one of those cases where it's a small town and a large industrial emitter. So most of the organic load was coming from that plant, and it represented quite a bit of energy. So rather than treating it aerobically and spending a lot of money on electricity and generating a lot of sludge, waste sludge that has to be disposed of, a much better idea is to take that energy that's still in the wastewater itself and turn it into biogas, which in turn gets transformed into electricity. So that system there at Milton, I believe there are two engines, one megawatt each engine. So as you can see, that would represent quite a bit of energy recovery, green energy recovery, from what otherwise would have been a waste and also a high cost for the town of Milton.
Well, what would be unique about your BVF reactors?
So the BVF reactor was developed back in the early 80s, is when the first installations went up. What's a little bit different from other anaerobic digesters is the fact that it's very robust, and it can accept high concentrations of suspended solids, which not every anaerobic reactor can do, and also fat, oil, and grease. So if you can imagine a wastewater from a food such as Chef Boyardee, you would expect the wastewater to have suspended solids, but those are all organic solids. And you would expect, if you look at the ingredients list, I'm sure there is oily material there. There's oil from the meat that might go into the product. There might be oils used for cooking. So there might be a way to recover those oils or to separate those oils from the wastewater. But in our case, we think that a better way to handle the fat, oil, and grease and the solids is to actually just put it into the digester itself and turn it into biogas.
And obviously with the cost of energy increasing, this is important. I think there also have been some developments in some cases where there's NOx control requirements for the biogas generation. There's been a handicap in that the siloxanes have caused SCR plugging problems, but I think those have been resolved now.
Yeah, and actually, yeah, and the siloxane is more of a problem when you're doing a anaerobic digestion of more of a municipal nature, more of a digesting municipal solids. Normally with industrial, especially food processing wastewater, you would not expect there to be so much silicon in the wastewater, so therefore not the generation of the siloxanes into the biogas. So I don't believe siloxane would be an issue at the city of Milton.
Oh, okay, that's good to know. Yeah, because my experience had just been with the municipal wastewater.
Yeah, there is, however, the need in some cases, or in most cases, to remove H2S, hydrogen sulfide. So that would be part of the treatment train for the biogas itself. That you can usually not avoid if you're trying to generate electricity.
Right, but that certainly is a lot simpler to remove with just an H2S scrubber than
That's correct.
The siloxanes. I know were a real problem, but I think there have been some breakthroughs with the selective catalytic reduction systems that are being used now. So,
agreed.
And then you have this other installation that just went, and I guess going to go on to the Mexican plant here. So
sure.
This would be a similar system.
Indeed. So the treatment system there is also based on the ADI-BVF reactor. That's been a very successful technology for us, and especially successful. The higher strength, the better for this reactor. And like I was saying earlier, it's able to treat high levels of suspended solids and fats, oil, and grease, which is not always the case. Often you have to do some kind of pre-treatment ahead of anaerobic digestion when you have a lot of solids. So then you have solids removal, and then you have to deal with the solids that you're removing or the fat that you're removing. So there's an additional disposal cost. In our case, we receive the suspended solids, and the way the ADI-BVF reactor is designed with a higher, with a longer retention time, we have the time to take those more complex organic materials and turn them into biogas. So at the plant in Mexico, it's a canning facility. They produce whatever is in season in that area of Mexico, central Mexico. You might have corn during part of the year that's coming out of the fields, and that's being transformed into canned corn for commercial consumption. You might have some jams, some sauces. There's of course, being Mexico, you'd have hot chilies, so those are being canned as well. So depending on the time of year, you'd have different production practices, and of course the wastewater being generated at different times of the year will change as well. And that's where we think as well the ADI-BVF reactor, being quite robust, is able to accept that variability in flow in wastewater characteristics, and again taking all of that organic load into biogas. That plant there in Mexico takes the biogas and utilizes it in a small, also generating engine to generate electricity, and the electricity is used right there at the treatment plant, so it reduces the plant's utility bill by mixing that clean electricity with energy from the grid.
So that's certainly very interesting, and of course now that you're with part of Evoqua, the secondary clarifier and much of any chemicals that you're injecting could be injected through the Wallace and Tiernan
Indeed.
systems, and so the whole.
Yes. So I think we're looking forward to seeing some synergies with other products from the Evoqua family and being able to integrate them into our overall treatment systems for industrial customers, for sure.
And I think another important point that you brought up here is the fact that at the Mexican plant here, they have different products going through and different times of the year and so forth, that if you're remotely monitoring and controlling this system, and there are these changes in product that may require some input from a anaerobic digester expert,
that's correct. Yes.
You would then be available to provide that expertise as part of a cloud-based system where you might have several tiers of experts, and for for the smaller problems or the less complex problems, they would be handled directly by the software supplier and the lower level people. But
that's correct, yes.
The problems get more complex, potentially having you people in there with how many decades of experience, right? When did you say that you people got into the anaerobic digestion?
Yes, so the experience at ADI Systems in anaerobic digestion specifically goes back to the late 70s, early 80s. I, of course, was not around at the time, but I have been with ADI for over 20 years. So there's a team of what I would call experts in anaerobic digestion that we would always be available to help our customers troubleshoot and improve treatment processes for sure.
Yeah. And then, of course, you've got the Evoqua knowledge as well. And you talk about the 70s. We were selling lots of our services, centrifuges and filter presses and so forth,
Indeed,
to a lot of separate companies, and all of a sudden they all got gobbled up by U.S. filters. So
that's right. Yeah.
so we go back to a lot of the individual companies, but there's a huge amount of historical expertise with all the companies here.
That is correct.
Well, Jose, thank you very much. It's been very instructive to get all that information. We'll look forward to working with you further, and we'll now move on to some of the other products that are used in the ConAgra plants. The ABB Dodge ball bearings are being used at in many of the in almost all the ConAgra plants. They standardize on these for their conveyors, and they have various different information platforms. One thing that maybe is a little out of context here, and I should have mentioned that before too, is that ConAgra, back on our first installation discussion there with Jose, they've actually contracted for that city waste, so they would be the ones that would be making the decisions about anaerobic digesters rather than the city itself. But another way they're expanding their activities is they're treating the wastewater from some of the industrial plants, such as Pilgrim, is paying $54,000 a month for ConAgra to handle their waste. So some more of the software that's involved here, IBM Software. Here is a more extensive analysis of the Rockwell automation systems provided by the systems integrator. And I'm not going to spend a whole lot of time on this other than, the fairly complex numbers of processes at the plant that are being controlled. The new projects, of course, have to be considered when you're putting in these systems, and all the SCADA and controllers and motor control. And as we say, the foot soldiers really are your valves and instrumentation. And in this particular case, they're using Anderson-Hauser, and then Emerson equipment, they're using the pneumatics controllers and Fisher and AT controls. There are always projects going on at these plants, and so from the supplier standpoint, if there's a new compressor going in, aseptic systems for the sucrose and so forth, that it's necessary information if you're working with these plants. The LinkedIn is, I think, revolutionizing the way that you can deal with individuals, because each individual, and there are 8,600 of them at ConAgra, is in LinkedIn because he wants certain information, and he can control that information because you can connect with individuals, and you select who you connect to, and you can disconnect from individuals. And so the opportunity is what we were talking about on that second slide there, that there would be individuals at ConAgra that are just interested in variable speed drives, or just interested in anaerobic digestion, etc. So now let's go into some of the components that are in these systems, and we decided to put a number of slides in on ABB because we do believe that ABB, Yokogawa, Siemens, GE, Rockwell, and companies of that with the wide scope of electrical equipment are well suited to be involved and to understand all these systems. So somebody like ABB, certainly since they're providing the automation platform system, needs to understand all these processes, but they also need to understand the ins and outs of automatic weighing, dosing, and mixing, and all the different processes within the plant. This happens to be one at DSM that ABB is involved in, and how you get efficiency improvements. And they have a range of products, from your manufacturing execution systems, process control systems, all these process control products, but they also have all these sensors and positioners in all these different areas. And the devil is in the detail with some of the IP signal converters and other things that can basically improve an operation. And your whole software system is no better than the accuracy of your level measurement, and where you have problems and can solve those problems with unique transmitters, it is a major step forward in cutting the cost of operations. And even things like motors that have a wide speed range can help optimize operations. Variable speed drives allow the process to achieve maximum energy savings, and many plants should be installing variable speed drives on applications where they do not now exist. So this is a big opportunity. Our beta site for this deep dive into an individual all these individual companies is, again, BHE, and BHE did undertake a very expensive study that indicated that there are hundreds of variable speed drives that should be installed just on the plants they have in Utah and on the Pacific Coast, let alone the ones in Mid-American and Nevada Energy and their renewables group. The understanding, if you're a drive manufacturer, the understanding of something as complex as recovering the screw energy, breaking energy in a centrifugal decanter centrifuge is important. And obviously the PLCs. And in the case of ABB, they also have the robotics, which obviously can be a very important addition to a process control system. Accenture is actively involved with analytics and strategic analysis in the industry. Alfa Laval is well positioned because of tremendous knowledge of all these food operations where they have the processes, and they additionally make the centrifugal separators, the control valves. They have the membrane equipment, and they're very big in heat exchangers, and they do provide the complete solutions as well. The performance agreement that they have at a Brazilian sugar company is really the predecessor of complete O&M operations, which with IIoT can now be accomplished. Alfa Laval is taking it to the next level with focusing on value streams like the fats, oil, and greases. And it is interesting that Jose has presented one aspect, which is you have a simple flexible system, and you can recover the energy from those fats, oils, and greases. Alfa Laval is taking the opposite tack here, that these are high cost disposal items, and that you can actually recover them and use them. And I think there are good arguments to be made for both under particular certain conditions, and where you have very valuable fats and oils, maybe that is true, where you or it might be complex to take them out. So I think there's a good reason to consider both options and make a decision with both of those options in mind. The details also involve the nozzles, because if you have a nozzle that's plugging and you reduce that plugging with a new nozzle, the system is going to be much more cost effective. The Cisco would be another supplier here. We're just going through alphabetically into some of the suppliers to the industry, and we're jumping back and forth between software suppliers, component suppliers, but just to show the breadth of information about all the components and systems that needs to be undertaken. And the wastewater treatment they're using, probably do a little bit of a deeper dive on the MVR. We use that as the example, as you recall, back in the beginning of the variable speed drives, and the need to have groups of people who are familiar with all the variable speed drive challenges within the corporation. But mechanical vapor recompression is a way of reducing the steam costs and is being increasingly used in the industry. And Colfax Howden is involved with providing the turbofans for this industry, and is in the food and drink and sugar and dairy industries. They are also supplying the Roots. They bought the Roots blower group, and so they're doing all, for the automatic conveying and other things, supplying those blowers. But also they have a whole range of pumps for food industry. So a lot of the components now will be available from Colfax. And of course the automated temperature measurement. And you have a lot of the consumables. The filter presses are a major production piece of equipment in many food plants, and the quality of filtration media, it can be upgraded at a considerable benefit. The overall view, certainly, of digitizing your manufacturing process is being provided by GE, who is obviously a leader in this whole area. GEA is a major supplier of these systems, but also doing predictive maintenance and service. They also make the compressors, and at the SugarCreek plant, which we have used for several examples here, they have a whole sequence which is explained here. And they do get involved from start to finish. They even just purchased a company that now monitors automatically monitors grain sampling and tracking, so from beginning to end. And Honeywell has not only all the systems, but even for smoke detection. And another thing, we're back on the training part that needs to be done here. And Honeywell is very good at providing training programs, but one would be on combustion safety to support the food and beverage industry. There's a number of these remote software solution providers, obviously key sorters for, our focus is less on something like the key sorters in the automated production lines than it is on anything that has to do with combust, flow, and treat. The Nalco 3D Trazar certainly reduces cooling tower maintenance in some of these systems, and you're measuring all the parameters related to the problems that you might have. And of course, you're adding more or less chemicals and avoiding pluggage of the cooling tower itself. So the software is increasingly sophisticated, and the programs, the process knowledge programs, and event management, enterprise resource planning are all available to the food industry. And there are a lot of these subsystems. Here's CO2 purification systems, where you can either purify the CO2 that's being delivered. In some cases, you're actually be able to make the CO2 at the plant as well. The pumps are critical, and here is an example of CPEX supplying pumps at Milton distillers. Schneider Electric, like ABB, has a wide range of products for the industry, from the automation down to many of the electrical components. Here's their Wonderware at New Belgium Brewery. Again, some more in the S section here of people doing the remote monitoring, which is a key part of the future, where all these plants are going to be monitored through cloud-based centralized systems. Another nozzle example here, and I think this is a good one because the nozzles can be affected by pump and other problems within the plant, or they can cause the problem. So all these things have to be integrated into your decision making as you try to make sure you get the drop size and coverage that you need. And lastly, you can take it all the way from, we took it to grain sampling on one end. You can take it even back further here, and Yara, who provides remote monitoring of urea and other things in the power industry, also provides remote water status for crops. So I think this is a good overall summary of the IIoT for the food industry. 2 weeks from now, we will have the coverage of the pulp and paper industry. And of course, all of this data does reside on our website under the report IIoT and Remote O&M. I would like to thank you for spending some time with us today, and we'll look forward to having you join us for future webinars. And this is Bob McIlvaine ending the session for today.